In this video, we're going to be solving some related rates problems involving cones. If you're interested in other related rates problems, I will link those videos in the description. Starting with number 1, it says the volume V of a cone is increasing at a rate of 26 pi cubic centimeters per minute. At the instant when the radius of the cone is 4 centimeters, its volume is 10 pi centimeters cubed, and radius is increasing at 1/3 centimeters per minute. Part A says, what is the rate of change of area of the base when the radius of the cone is 4 centimeters? So I like to start with writing what we know. We know that the volume is increasing at a rate of 26 pi cubic centimeters per minute. So that's going to be our dV/dt. And our dV/dt is 26 pi centimeters cubed per minute. We're making 26 pi positive because my volume is increasing. If the volume were decreasing, we would make it negative. And then I also want to write out what I want. So it says, what is the rate of change of the area of the base? So I want dA/dt, and that's when the radius of the cone is 4 centimeters. And then they also tell us in the problem that when the radius of the cone is 4 centimeters, the volume is 10 pi centimeters cubed, and dr/dt, the radius, is increasing at 1/3 centimeters per minute. So I'm going to say dr/dt is 1/3 centimeters per minute. So I need a formula for area. The area of the base, our base is a circle. So area of a circle is pi r squared. Once I have my equation, I'm going to take the derivative with respect to t on both sides of the equation. And this is implicit differentiation. So if you need help with implicit differentiation, I will have that video in the description. But derivative of a with respect to t is just dA/dt. Derivative of pi r squared is going to be 2 pi r dr/dt. And we want to solve for dA/dt, so dA/dt, now I'm going to plug in, is 2 pi. My r is 4, and they said our dr/dt is 1/3. The rest is simplifying. I have 4 times 2 is 8, so we have 8 pi over 3. And our units, area is centimeters squared, time is minutes. And that is part A. Moving on to part B, it says, what is the rate of change of the height of the cone when the radius is 4 centimeters? So I have the same know. I know dV/dt is 26 pi centimeters cubed per minute. But now I want the rate of change of height of the cone. So I want dH/dt when the radius is 4 centimeters. So now I want to talk about the radius and I want to talk about the height. And I know volume, so let's do volume of a cone, and that equation is 1/3 pi r squared h. Let's take the derivative with respect to t on both sides. On the left side, we get dV/dt. On the right side, we're going to have to do a product rule because I have r squared and I have h. I'm going to put pi over 3 outside the product rule. Derivative of r squared is 2r dr/dt. And I'm going to leave the h. Plus, I'm going to leave the r squared. Derivative of h is dH/dt. Now I want to plug in. I know dV/dt is 26 pi. I have my pi over 3. 2, my r is 4 centimeters. dr/dt, I'm going to pull the same one from part A, that is 1/3. And then I want you to notice that we don't know h, so I'm going to leave that blank for a minute. R is still 4, so 4 squared. And then we are solving for dH/dt. So I need to figure out what h is. In order to do that, I'm going to do a little cone on the side. And I want h when r equals 4. So I'm going to label the radius 4. And I want h. And then we also know from the prompt that the volume is 10 pi centimeters cubed in this moment. So I know in this moment the volume is 10 pi centimeters cubed. And I'm going to use that same volume formula, 1/3 pi r squared h. And I'm going to plug in and solve for h. So I know volume is 10 pi. I have 1/3 pi. Our radius is 4. And notice now that we will be able to solve for h. I'm going to do that right here. I can divide by pi on both sides. I'm going to multiply by 3. So 30 equals 4 squared is 16. Divide by 16 on both sides, and we have 30 over 16, which simplifies to 15 over 8. So h is 15 over 8 when the radius is 4 and the volume is 10 pi. So I'm going to put 15 over 8 in my problem. The rest is simplifying and solving for dh dt. So I'm going to divide by pi on both sides. I have 26 equals 1/3. Let's do some canceling. 4 times 2 is 8, so I'm going to cancel out 8s. 15 divided by 3 is 5. So I have a 5 plus 16 dh dt. I'm going to multiply both sides by 3. 3 times 26 is 78. Subtract 5, we get 73. And I get that dh dt is 73 over 16. And for units, height is in centimeters, time is in minutes. So centimeters per minute. That is part B. We have one more example. It says a water tank is the shape of an inverted cone with a base radius of 3 feet and a height of 5 feet. So those measurements are not going to change. So I'm going to label those on our picture. My radius is always 3 feet, and the height of my cone is always 5 feet. It says if water is being pumped into the tank at a rate of 4 feet cubed per minute, what is the rate that the water level is rising when the water is 2 feet deep? So I know since water is being pumped into the tank at this rate, that is going to be volume. So we're going to say dV dt equals 4 feet cubed per minute. And we want to know the rate that the water level is rising. So if you think about water in the tank and then the water level is rising, that water level is this height. So I'm going to say dH dt. When the water is 2 feet deep, that's when the height is 2 feet. That's what we're looking for. So we're going to be using volume and height. We're going to use volume of a cone again, 1/3 pi r squared h. Let's take the derivative with respect to t on both sides. I have that same derivative as the previous problem. So 2r dr dt h plus r squared dh dt. And then we're going to plug in dV dt is 4. R, now keep in mind that when we're talking about R in this equation, it's the radius of the water level. And we don't know that, so I have my 2. I'm going to leave my R blank. We also don't know dr dt, so I'm going to leave that blank for a second. H at that moment is 2, so I'm going to plug in 2. We need that r again. And then dh dt is what we are solving for. So I'm going to write dh dt. Let's do some side work to figure out r and dr dt. I want you to notice that we have similar triangles. So starting with, I have this orange triangle. Where this length is 3, this length is 5. It's a right triangle. And then I have this smaller triangle where this is R and this is H. So let's use similar triangles. I'm going to do a proportion. I'm going to say 5 over H equals 3 over R. I don't like fractions, so I'm going to say 5R equals 3H. And one of the things that we need is R. So I'm going to say R is 3H over 5. And I want R when H is 2. So this is going to be 6 over 5. So our R, I'm going to put it in our equation, is 6 over 5. Now we also need dr dt. So I'm going to divide by 5 on both sides, 3/5 H. I'm going to take the derivative with respect to t on both sides because we want dr dt. And we get dr dt equals 3/5 dh dt. So that's going to be our dr dt. I'm going to plug it in, and it's okay that we have dh dt in it because that's what we're solving for. And the rest is solving for dh dt. So let's do that. I have my 4. Let's see if we can cancel anything. Doesn't look like it for the first term. So we're going to have 4 times 18, which is going to be 72 over 25 dh dt, plus 6/5 squared is 36 over 25 dh dt. Next, I have like terms, so I'm going to add the coefficients. My denominator is 25. 72 plus 36 is 108. Let's multiply by 3 over pi. I get 12 over pi equals 108 over 25. So dh dt equals 12 over pi times multiply by the reciprocal. Simplify the 108 and the 12. And we get 9. 108 divided by 12 is 9. So dh dt equals 25 over 9 pi. Let's do our units. They said that height is in feet, time is in minutes. That is your dh dt. There was a second way that we could have solved this problem. I could have noticed in the beginning that I would have needed r and h, and so I could have done this work at the beginning. So what it would have looked like is I would have started with my volume equation, and I would have gotten that r is 3h over 5. So I would have substituted r with 3h over 5. And then simplify, I have 9 over 25 h squared times h. And this would have been 3 pi over 25 h cubed. And then when I take the derivative with respect to t on both sides, I would have gotten dv dt equals 9 pi over 25 h squared dh dt. And then when we plugged in, we know that dv dt is 4. So let's put a 4. And we want dh dt when h equals 2. So let's plug in 2. The 4's cancel on each side of the equation. dh dt is 25 over 9 pi. And then same unit, feet per minute. So that is a second way we could have done this last problem. Those were a few examples of related rates questions with cones. Thank you for watching.